Welcome to Best Academy TV. In this series, I'll be teaching on conservation of linear momentum. Conservation of linear momentum. So let's take this question here to understand what conservation of linear momentum is. Okay. Now, they said two billiard balls collide in a perfect elastic collision. Ball A has a mass of 0.8 kg and an initial velocity UA of 3 meters per second. Ball B has a mass of 0.3 kg and an initial velocity of UB to be equal to minus 2 meters per second. We are asked to determine the velocity of each ball after collision. Okay, so class, before we solve this question here, we have to understand the question, but let's first of all write solution first. Okay, let's write down solution. Let's understand this question here, class. Okay, now they say two billiard balls collide in a perfect elasticity. Okay, so this elasticity is a perfect elasticity. Please take note. We have this to be perfect elasticity. So we are going to know what a perfect elasticity is. We are going to know what a perfect elasticity is. Please take notes. Collision. Okay. Now, ball A has a mass of, for ball A, we have a mass to be 0.8 kg, and the acceleration, sorry, the velocity entitled to that ball A is 3, that is the initial velocity there is 3 meters per second. Please take notes. And ball B has a mass of 0.3. Ball B has a mass of 0.3, and the velocity attached to it, the initial velocity attached to it is this, that is minus 2 meters per second. Please take notes. We are asked to determine the velocity of each ball after collision. Okay, in conservation of linear momentum, we have 3 stages. We have before collision, we have during collision, and we have after collision. Please take notes. So after collision is always for final velocity. Okay, so whenever you have a question on collision, the formula we use to solve that particular question is formula for conservation of linear momentum. Whenever you have any question on collision, the formula we use to solve that particular question is the formula for conservation of linear momentum. Please, the formula we use to solve that particular question will be the formula for conservation of linear momentum. Please take note. Okay, so this question here is on collision, so I will apply the formula for conservation of linear momentum, and this formula states that or the principle states that the sum of the momentum before collision is equal to the sum of the momentum after collision. So we have something like this, class, that is momentum before collision is equal to momentum after collision. So the formula for momentum is mass times velocity. Please take note. So before collision here, class, I will have this to be, if I have an object like this is my object here, this is before collision, this is my object here. Okay, I will have the object this mass before collision, mass 1, this mass 2. So before collision, the velocity will be an initial velocity, that is u1 here, this is u2 here. Okay, so class, after collision, I will have this particular object, the same object here. So this is mass 1. Mass 1 remain the same, but the velocity will change from initial to final, that is v1. Please take note. Okay, v1. So this remain the same, the mass remain the same, m2. Velocity will change from initial to final, that is v2. So writing the sum of the momentum here before collision, the sum of the momentum before collision, and also writing the sum of the momentum after collision, that is this here, I will have this to be my equation 1, that is before collision. I will have this to be my equation 2, that is after collision. So the formula will be m1 u1 plus m2 u2 is equal to, after collision, I will have m1 v1 plus m2 v2. So this formula here is a formula for conservation of linear momentum. Please take note. This formula here is the formula for conservation of linear momentum. Okay, but in this question here, in this video here, we are given a question, and the equation is on perfect collision, that is perfect elastic collision. Please take note. So when we say about perfect elastic collision, we are saying about an object that does not stick together. Okay, if the objects don't stick together after collision, if the objects don't stick together after collision, we call it elastic collision. Please take note. But if the objects stick together after collision, we call it inelastic collision. Please take note. If the object, listen to me carefully, if the objects don't stick together after collision, we call it elastic collision. But if the objects stick together after collision, we call it inelastic collision. Please take note, okay? So in this question here, class, we have this to be perfect elastic collision, okay? So for perfect elastic collision, is always indicated in the question there. Please take note. So for every perfect, or for every elastic collision, please take note, for every elastic collision, we have two formulas to solve that. The first formula is the formula for conservation of linear momentum. The second formula is the formula for conservation of the velocity. And this is the formula here we use. This is the formula here we use. That is, this is the first formula we use. The second formula we use is this. That is u of a, sorry, u of 1, since we are using 1 for now. U of 1 plus u of 2 is equal to v of 1 plus v of 2. This is my second formula to use. This is equation 2, okay? Now, let me stabilize this here. Now, whenever you have a collision that is inelastic collision, we use only this particular formula here to solve that. But if that collision is inelastic, we use these two formulas here. We use formula 1 and we use this formula 2. So this equation here is in elastic collision. So we are going to use formula 1 and formula 2 to solve this question here. So please don't be confused here. It's always indicated in the equation if the collision is elastic or inelastic. Please take note. So the other way around to know inelastic is when the objects stick together. The objects stick together after collision is called inelastic. Please take note, okay? So now let's try to solve this, class. Now solving this here, I have to explain the equation perfectly. So now let's explain this question here, class. They said two billiard balls collide in a perfect elastic. So that word perfect elastic means that I'm going to use two formulas. The first one, conservation of linear momentum. The second one, conservation of velocity, okay? Now, we are given ball A, okay? They say ball A. Let's interpret that here. Okay, let's interpret this here. We are given ball A, that is, this is ball A. Ball A, the mass of ball A from the equation here, the mass of ball A is 0.8 kg. Now, this ball A is moving to a particular initial velocity because this is before collision, okay? Now, since the velocity is plus, so if the velocity is plus, it means that it's moving to positive direction. If you have your Cartesian plane like this side here is for plus aspect. This side here is negative. Please take note. So the velocity of ball A is positive. So the direction of the velocity will take this shape here. That is U of A is equal to 3 meter per second. Okay, please take note of this. The direction of velocity is always very, very important. Okay, it's very important. Sorry for that. So we have something like this ball B. This is ball B, and the mass in ball B is 0.3 kg. So the velocity of ball B in the equation there is negative. So it will be indicated in this direction here. Please take note. So our U of B is equal to plus 2 meter per second. I'm not indicating the minus here because the direction, that is this arrow here, is indicating that this 2 here is already negative. Please take note. So we don't indicate negative, also indicate the angle to be negative. It will be positive, okay? So this angle, this arrow here is indicating that this 2 meter per second is in the negative direction. This arrow here is indicating that this 2 meter per second is in negative direction. So at that point, you don't need to put negative here. Please take note of this, okay? So that is before collision. So after collision here, we are going to have something like this, a sketch like this after collision. Remember, the mass remain the same. We are going to have a sketch, the same ball, ball A and ball B. Ball A, this is ball A. So mass remain the same. Mass A is 0.8 kg. There's no velocity here after collision, okay? Now, this is ball B. The mass remain the same. Mass B is 0.3 kg. There's no velocity here, so it means the same like that, okay? So we know that this question is the collision here, sorry, is perfect elastic collision, okay? And we say that for every perfect elastic collision, we use two formulas. The first one is conservation of linear momentum, and the second one is on conservation of the velocity. Please take note, okay? So we apply this formula here. Since this question is on perfect elastic, so we'll have this to be this. We apply, okay, let's take a note here. Note, to solve a perfect elastic collision. Note, to solve a perfect elastic collision, we apply the following formulas. Okay. Now we apply the following formulas. The first one here is for conservation of linear momentum, but writing this in respect to the equation given to us there, I will have this to be m a instead of m1, u a instead of u1, plus mb instead of m2, ub instead of u1 is equal to ma instead of m1, va instead of v1, plus mb instead of n2, vb instead of v2. Please take note. Now the next one is this is for Formula 1. The next one is conservation of velocity. That's ua plus ub is equal to class va plus vb. So I have this to be Formula 2. Okay, now let's apply them. Let's replace the values given to us there. So from equation 1 here, we have this to be 0.8 into 3, that is for UA, remember, plus 0.3 into minus 2. I'm using this formula here. Please take note. I'm using this formula here, okay? Is equal to class 0.8, sorry, is equal to 0.8 VA plus 0.3 VB. Please take note. 0.3 VB. 0.3 VB, okay? So class, let's simplify this. Let's simplify this one here. Let's simplify this one here, okay? When you simplify this, we have something like this. This class, we have something like this. That's 0 times 0.8 times 3 plus, remember, sorry for this, 0.3 times minus 2 will give us minus 0.6, okay? While 0.8 times 3 will give us 2.4. 0.3 times minus 2 will give us minus 0.6, okay? So when you do that, we have something like this. That is 2.4 minus 0.6 is equal to 0.8 VA plus 0.3 VA. Please take note. Sorry, VB plus 0.3 VB. Okay. So 2.4 minus 0.6 is 1.8 is equal to class 0.8 VA plus 0.3 VB, okay? So this is from our Formula 1, okay? Now let's use our Formula 2. This is our Formula 2. Remember, we are using two formulas here because the collision is for perfect or for elastic collision, okay? The collision is for elastic collision, okay? So let's apply this second one here. This second one here. When you do that, we have something like this class. Replacing that, we have 3 that is using u VA plus UB equal to VA plus VB. So replacing this, we have this to be 0.8, sorry, we have this to be, replacing that, we have this to be 3 3 plus into minus 2 is equal to VA plus VB. So when you simplify this, plus times minus is 1, that is 3 minus 2 is equal to VA plus VB. So 3 minus 2, sorry, 3 minus 2 is 1. I have this to be 1 is equal to VA plus VB. So this is from my equation 2. So class, substitution using substitution method of solving simultaneous equation. Now, using substitution method of solving simultaneous equation here, that is using substitution, sorry, method of solving simultaneous equation. So now let's make VA the subject of formula in equation 2. So we have this to be VA, that is from this expression here, making VA the subject, VA will be equal to class 1 minus VB. I will call this equation 3. So anywhere you see VA in equation 1, you replace VA as 1 minus VB. Anywhere you see VA in equation 1, you replace that as 1 minus VB. Okay, now let's replace VA as 1 minus VB in equation 1. That is replace VA into equation 1. We have 1.8. Remember from equation 1, 0.8. So into 1 minus VB plus 0.3 VA. Please take note. Okay, now let me explain this. So in this particular position here, I'm replacing it as 1 minus VB. So when you do that, we have something like this. Okay? Please don't forget. So the next thing I'm going to do here is to open this bracket here. Okay? So open the bracket, I will have 1.8. I will have 1.8 is equal to plus 0.8. That is 0.8 times 1 will give us 0.8 minus 0.8 times VB will give us 0.8 VB plus 0.3 VA. Please take note, okay? Sorry, this is VB. Sorry for that, okay? Sorry, I'm very sorry for that, okay? This is VB. This is VB. From this thing, this is VB. VB here. Okay, now let's go back. This is VB, okay? Look at it here. VB, okay? 0.3 VB, okay? Sorry for that mistake, okay? So when you do that, class, I will have this to be 1.8 equal to 0.8 minus 0.8 VB plus 0.3 VB, okay? Now class, if you take light terms here, when you take light terms here, I will have this to be 1.8 minus 0.8 is equal to class um is equal to minus 0.8 VB plus 0.3 VB. Please take notes, okay? So 1.8 minus 0.8, the result is 1, is equal to class minus 0.8 VB plus 0.3 VB, just like minus 0.8 plus 0.8, okay? 0.3, sorry. I'll have this to be minus 0.5 VB. So our purpose here is to make VB the subject letter. So to make VB the subject letter, I have to divide both sides by what is attached to VB. Divide here by minus 0.5. Apply the same thing here, minus 0.5. So this guy will cancel this guy. I'll be left with VB. Please punch your calculator. 1 divided by minus 0.5. I will have this to be minus 2 meter per second. So the value for VB is minus 2 meter per second. So anywhere we see, to get our VA, we replace VB as minus 2 meter per second. But remember that from equation 3, we have V